In this video, we are going to have a review for objectives FN6 through FND. So FN6, the objective is describe the transformations and graph a function based on transformations, the functions, i.e. vertical or horizontal shifts, vertical stretch or compression, and reflection across the x-axis. This question says to draw the graph of f of x equals 2 parentheses x plus 3 parentheses squared plus 2. Include in your work a description of the transformations. Now, I want to point out that this question does in fact have an add work button, so here's what my work is going to consist of. First, I notice that this function has a plus 3 inside the parentheses. Now, we know that that is going to be a vertical, or rather a horizontal shift left or right. Now, if what's inside there is a plus, that means we're moving to the left by that many units. And if it is a minus, so x minus 3 would move to the right 3 units. So this is going to be a shift left by 3 units transformation. It's also worth noting, before I even state that this has a parent function of x squared. It's a parabola, or it's quadratic. So we have a quadratic function that is shifted to the left by 3 units because of the plus 3 in the parentheses. We also have a plus 2 outside of our parentheses. Okay, so that indicates this is going to be shifted up. Have a shift up by 2 units. And let me go back actually and point out that this squared right there is what indicated it was a parabola. All right, so 2 parentheses x plus 3 squared plus 2. Because of the squared outside the parentheses, it's a quadratic function. The plus 3 in the parentheses indicates it's going to shift to the left 3 units. And because of the plus 2 at the end, it's shifting up 2 units. And finally, we have this 2 that's multiplied by x plus 3 squared. That indicates that we have a vertical stretch. Vertical stretch by a factor of 2. Now, if that were, for instance, a negative 2, that would also indicate we have a reflection across the x-axis. So we have vertical stretch, we have a horizontal shift left by 3, and a vertical shift up by 2. Now, to graph this function, there are 2 things that I really need. One, I need the vertex. And this applies to any parent function, but in particular, with quadratics, we call that special anchor point the vertex. And then also, we need to include one additional point. Now, that one additional point, we're going to determine where that is based on the vertical stretch. So I'm going to go ahead and put 1 point. Originally, it would be at 0, 0, because the parent quadratic function begins at 0, 0. But because we are shifted to the left 3, and up 2, this will be, my vertex will be at negative 3, 2. So let me put a point there at negative 3, 2. And then because we have a vertical stretch by a factor of 2, that indicates to me that I'm going to go up 2 and to the right 1 from that. That is vertical stretch of 2, because typically the function would go up 1 and to the right 1, which would be negative 2, 3. So in this case, it's negative 2, 4. And then because quadratics are symmetric, I know there will be a point here. But again, the way this is set up is it's automatically going to graph a quadratic. All right, so that will just connect the dots. And then that shape is filled in based off that 1 point and the symmetry. Now, all of the description that I wrote here to the right, that is actually what the work would be for this. So make sure that you take a picture of that and attach it as work for the FN6. All right. The next objective we're going to look at is FN7, which is going in the reverse direction. So determine the equation of a graphed transformation. So we already have the graph. We're determining the equation. So in this next question, or the first question for this objective, this has a V shape. Okay, so this graph that we see has a vertex at the point -3, -2, and it has a slope of 1 going to the left and a slope of -1 going to the right. So it's decreasing to that point -3, -2 at a rate of 1 unit y per 1 unit x, and then it increases in the opposite direction. Now, because of that sharp corner that we see there, this indicates this would be an absolute value function. So I'm going to go ahead and write that off to the side. That is, it's going to be an absolute value of x function. I already noticed the vertex was shifted to the left by 3, from 0, 0 to -3, -2. So the left 3 units. And then we also notice it's been shifted down from 0, 0 to -3, -2. So it's shifted down by 2 units. Now, using what we were talking about in FN6, we have multiple choice options here. So f of x equals absolute value of x minus 3 quantity minus 2. Second choice, f of x equals absolute value of x plus 3 quantity minus 2. Third choice is f of x equals absolute value of x minus 2 quantity plus 3. And f of x equals absolute value of x plus 2 quantity plus 3. So because it is shifted down 2, we know it's going to be either of the first two, ending with a minus 2 or ending with a minus 2. So those are the only two choices there. But then because it's shifted to the left, remember, when you shift to the left, you have an x plus something. If it's to the right, it's an x minus something. So this should be absolute value of x plus 3 quantity minus 2. And again, there's not much work to really go with that. What I've written on the right, those bullet points of the description, that is really all that you could put for this particular question, so make sure you attach work for that. Now, there's a second question for this, because we have determined the equation of a graph transformation. I've got one absolute value function, and the second one is a transformed quadratic. It says write an equation for the function shown below, which is a transformed, shifted, and scaled version of f of x equals x squared. And we have to write the equation g of x. So we want to notice with this graph, the vertex is at -1, 0. And there are 2 points that are given. So I'm going to write this as v parentheses -1, comma 0, close parentheses. That's my vertex. And I have 2 points. And because a parabola is symmetric, we only really need one. We have the point 1, 8. And then we also have the point -3, 8. So I want to add the point 1, comma 8. Now, the vertex tells us how we're shifted, if it's left, right, up, and down. And because the vertex has a y-coordinate of 0, this has not been shifted vertically, okay? But it has been shifted horizontally to the left by 1, which means that our function will begin by saying it is parentheses x plus 1, close parentheses, squared. Remember, the plus 1 indicates to the left. X minus 1 would be to the right. So, of that, we don't have a horizontal shift. However, we do know that this function is scaled, right? It is scaled because that is stretched. So, I'm going to write this as f of x, or g of x actually is what it's called. G of x equals a, parentheses, x plus 1, parentheses, squared. Because I don't know what that stretch factor is, I'm leaving the a there. Now, to be sure, what I'm going to do is take my point 1, 8. That means my x value is 1 and my y value, my g of x value, is 8. So I'm going to replace those in this equation and say 8 equals a, parentheses, 1 plus 1, close parentheses, squared. So again, I'm replacing x with 1 and my g of x with 8. And I'm going to solve for what the a value is. So simplifying the right-hand side, 1 plus 1 in parentheses squared. 1 plus 1 is 2. 2 squared is 4. So this equation becomes 8 equals 4a. And then I can divide by 4 on both sides to see that a equals 2. So my function is 2, parentheses, x plus 1, close parentheses, squared. So we can take that one of those two given points and determine what the a is. Now sometimes you can just look and say, oh, it appears this function, if I go up 2 and over 1, I have a point. So that would indicate my a is 2 as well. But algebraically, we can take the point and calculate what that is. All right, that's all for FN7. We have these two functions to graph for that, or equations to write for that. All right, now, FN8, for this objective, we're told to determine the domain of a continuous graph or equation, a polynomial, rational, or a radical type. So there are actually 3 parts to this. The first is find the domain of f of x equals the square root of 9x plus 6. Now, we know from our notes that to find the domain of a radical function, we have to take the radicand. That is what is underneath the radicals. In this case, that's 9x plus 6. We're going to take 9x plus 6 and set that greater than or equal to 0. Now, we're going to solve this as an inequality, but there's one rule to remember when you're working with inequalities, as is different from equations, and that is if you ever divide or multiply by a negative, we change the sign from greater than to less than to greater than. So I'm going to solve 9x plus 6 is greater than or equal to 6 by subtracting 6 from both sides. So that is a 9x is greater than or equal to negative 6, because 0 minus 6 is negative 6. Dividing by 9 on both sides. Now, if x is greater than, and let's see, 6 over 9 would reduce to negative 2 over 3. Now, I didn't have to change my sign here, but again, be aware that if you have to divide by a negative as you're going through, divide or multiply by a negative, it's going to change that sign from a greater than to a less than. So the final thing I have to do is actually write this inequality as an interval notation. So I have x is greater than or equal to negative 2/3, which indicates to me that my interval begins at negative 2/3 and increases to the right. This is domain, so I'm going left to right. So from negative 2/3, then greater than that is to the right. So this would be bracket negative 2 over 3, comma, infinity, parentheses. That would be the interval that represents x is greater than or equal to negative 2 over 3. Now again, I didn't say this in the last question. Remember, when there's work to be shown, I'm showing you what I think is the appropriate amount of work. When there's work to be shown, make sure you click Add Work and submit that as well. All right. Well, the next question for FN8 is find the domain of the function f of x equals 1 divided by 6x plus 7 as a quantity. And the question is, what's the only value of x not in the domain? So when we have a rational function, as we had to do in the last unit actually, we will take the denominator, okay, in this case 6x plus 7, and we want this to be not equal to 0. Well, if we were to solve this equation, I'd subtract 7 from both sides so that 6x is not equal to negative 7. And dividing by 6 on both sides, I see that x is not equal to negative 7 over 6. Well, because x cannot be equal to negative 7 over 6, the only value that x cannot be is negative 7 over 6. That'll be the answer that goes in my box here. Negative 7 divided by 6. And then, of course, there's that work that goes with that. Now, because these 3 questions that we're going to see are all on this one objective, you can put all the work onto one of these 3. Just probably you want to put it on the first one. That's just a good idea so that I can find that work. All right, well, our last question for FN8 is find the domain of the function graphed below. Express this in interval notation. So to describe this graph, we first have a point farthest to the left that's negative 2, 0. It's a closed dot. The graph increases to a point of 0, 4. And then it decreases from there to the point 1, 3. So again, begin at -2, 0, increases to 0, 4, and then decreases to 1, 3. And actually 1, 3 is an open circle where -2, 0 is closed. So if we're trying to say what the domain is, that's the important thing here. Those are the values going from left to right. So the furthest to the left that this function gets is an x of -2. And because that is a closed dot, I'm going to do an open bracket. So open bracket -2, comma. Then the furthest to the right that gets is an x value of 1. So I have bracket -2, comma 1, and then a closed parenthesis because that 0.13 was open. Now, some versions of this question may actually ask you for the range as well. In that case, you're talking about the values from the lowest to the highest. So our lowest y value would be 0, but our highest value would be 4. So the range would be, I'll just go ahead and write it here. The range would be open bracket 0, comma, and then the highest value is 4, comma 4, and then actually that would be a closed bracket because it attains a value of 4. So if you were asked to also find the range of a continuous graph, that's how you do it, from lowest to highest. Here we're most concerned with the domain, so from left to right. All right, for FN9, this objective says determine a combination, sum, a difference, a product, or a quotient of two functions, find the domain, and evaluate the resulting function. So there are two questions that actually have several parts for this. The first one says, given the following functions, evaluate each of the following. I have f of x equals x squared plus 4x minus 5, and g of x equals x plus 5. And the first part here says, find f plus g, that's a function in parentheses, f plus g of -2. Now there are several ways to determine this, so I'm going to show you, I'll try to show you both ways if I have a little bit of time here. So f plus g of -2 means I'm going to take the functions f and g and add them. So over to the side, I'm going to say f plus g of -2, and that equals parentheses, my f of x, that's x squared plus 4x minus 5, close parentheses, plus my g of x, which is x plus 5, that in parentheses. But I'm going to replace each of my x values with a -2. So I'm going to go back and erase my x values, and I'll read that again with a -2 replaced there. So I have parentheses, and then in parentheses -2 squared plus 4 times -2 minus 5, close parentheses, plus -2 plus 5. Okay, so I'm adding the two functions, but I'm evaluating each of them. Now, the other way to actually talk about this would be that you would find f of -2 plus g of -2, which means you evaluate f at -2 and you evaluate g at -2. I've actually done that same thing here by doing this. So ultimately, they find the same values. So simplifying that, I have -2 squared is 4. 4 times -2 is -8 minus 5. So that would be 4 minus 8. It's -4. So that should result in when I subtract 5, of -9. So I have -9 plus, and then -2 plus 5 is 3. Let's see, I believe that all sounds correct, but I'm still going to use my calculator to evaluate that just to make sure. -2 squared plus 4 times -2 minus 5 is -9, okay, and -2 plus 5 is 3. So I'm going to say -9 plus 3, which is -6. So f plus g of -2 is -6. Now the next question is f minus g of -2. The only difference in this is going to be that in between the two functions, I will change that plus to a subtraction. So I'm going to write this one as f of negative 2 minus g of negative 2. Since I've already actually found those two values, I'm going to replace f of negative 2 with negative 9 minus g of negative 2, which we found is 3. So negative 9 minus 3 is negative 12. So f minus g of negative 2 is negative 12. Now, of course, if your function, now mine, I have f plus g of negative 2, f minus g of negative 2, f times g of negative 2, and f divided by g of negative 2. If that x value, the input, changed, of course, that would change your answers. All right, well, the next question is the f times g of negative 2, which that's going to be equal to f of negative 2 multiplied by g of negative 2. Since we've already done the work of evaluating those two, f of negative 2 is negative 9 multiplied by g of negative 2, which is 3. So if I multiply negative 9 by 3, I see that's negative 27. So that my third answer is negative 27. Now, finally, f divided by g of negative 2, that is the equivalent of saying f of negative 2 divided by g of negative 2. And again, we've already determined that f of negative 2 is negative 9, and g of negative 2 is 3. So this is negative 9 divided by 3, which is negative 3. So f divided by g of negative 2 is negative 3. All right, now this is evaluating a combination of functions. Now, specifically on the next question, we are going to need to divide these two functions we're given and find the domain. So on this next question, I have f of x equals x squared minus 16, and g of x equals x minus 4. So the question says find f divided by g of x. So f divided by g of x is equal to f of x divided by g of x. Since f of x is x squared minus 16, that'll be my numerator, divided by x minus 4. That's my denominator, that's g of x. Now, x squared minus 16 factors as x plus 4, in parentheses, multiplied by x minus 4. That's still over x minus 4, but we might notice that something simplifies there. The x minus 4 is a common factor, so this is equivalent to x plus 4. That is my first box. Okay, f divided by g of x is x plus 4. However, the domain of this is not based off of the x plus 4. It's based off of the denominator that we see. Because we have a denominator x minus 4, x minus 4 cannot be equal to 0. That's the denominator. So that means that x cannot be equal to 4. And that is the second question. The domain f divided by g of x is not equal to 4. That's what I'll put in my box. And that covers FN9, okay, evaluating a combination of functions and also finding the domain and finding the function. So we've actually just found the combination where we divided. We found the domain of that because that's domain restriction. And then in the last question, we evaluated for all three of those, or all four of those. Addition, also called a sum, okay, the difference, the product, and the quotient. So that covers that objective. Now, this next objective is a special, separate kind of combination called the composition. So FN10 says determine the composition of two functions, the domain, and evaluate the resulting function. And the question is, given that f of x equals 9x plus 8 and g of x equals 2 minus x squared, calculate f of g of 0 and b, so that's part A. Part B is g of f of 0. Right, so I'm not going to actually write what the composition is, but we have done that in our notes. Since we want to calculate f of g of 0, the very first thing we need to do, I'm going to rewrite that, f of g of 0. What I need to determine first is what g of 0 is. And so over here on the side, I'm going to say g of 0, and that's going to be equal to 2 minus 0 squared, based on the function g of x equals 2 minus x squared. Now, because 0 squared is 0, 2 minus 0 would be 2. So g of 0 equals 2. So going back to f of g of 0, that's going to be the same as saying f of 2, because we found g of 0. Well, f of 2 would be replacing f in the function f of x, 9x equals 9x plus 8, replacing the x in f of x with 2. So this would be 9 parentheses 2, close parentheses, plus 8. 9 times 2 is 18. 18 plus 8 is 26. So f of g of 0 is equal to 26, and that's the first part. Now for part B, g of f of 0, the big distinction is we're changing the order. So underneath here, I'm going to write g of f of 0. Now, to evaluate that, we need to find what f of 0 is. So again, I'm going to go over to the side. F of 0 is equal to 9 multiplied by 0 plus 8. That's because our function is 9x plus 8. So 9 times 0 is 0, plus 8, that will be 8. So f of 0 equals 8. So I'm going to go back and write that. My question is really asking, g of f of 0 equals g of 8, because of that fact we've just determined. Now, since g of x is 2 minus x squared, g of 8 is going to be 2 minus parentheses 8, close parentheses, squared. Now, 8 squared is 64, so this becomes 2 minus 64, which will be negative 62. So this will be equal to negative 62. So I can write my answer, g of f of 0 equals negative 62. And of course, just like many of the other ones, we now have some work that we really need to submit. So make sure you use that add work button as often as necessary. Now, our final objective in this set of practice objective checks is FND. Determine if a function is one-to-one, and if so, determine the inverse of the function. So, of the two questions, the first is answer the following true or false question. If the graph of y equals f of x passes the vertical line test, let me read that again. If the graph of y equals f of x passes the horizontal line test, then f of x has an inverse. Now, we've talked about the vertical line test with telling us something's a function. However, we know now that passing the horizontal line test tells you if a function is one-to-one. If a function is one-to-one, then it has an inverse. So this statement is, in fact, true. Now, it's also true, this isn't what the question asks, but it's also true that sometimes we restrict the domain of a function that isn't one-to-one, that doesn't pass the horizontal line test, so that it can also have an inverse. All right, now, the second question here is to find the inverse of a function. So we have let f of x equal 12x plus 13, and we're asked what is f to the negative 1, or f inverse of x. Now, the general strategy here is we'll take our function f of x equals 12x plus 13. We will replace f of x with y, just for ease of calculation here. So this will be equal to y equals 12x plus 13. So f of x equals y. That's often our first step. Our second step is going to be to replace y with x and x with y. So we'll switch those two. So my new equation will be x equals 12y plus 13. And then the final step is solve for y. I'm going to solve that for y. So I'm going to subtract 13 from both sides. I have x equals 12y plus 13. Subtracting 13 produces x minus 13 equals 12y. And then dividing by 12 on both sides, I find the equation y equals x minus 13 quantity over 12, which is also, I could write this separately as 1/12 x minus 13 over 12. Those are equivalent ways to write the inverse. So in my box, I'm going to write x minus 13 all over 12. And again, there is clearly some work that goes with this, so make sure you submit that in the appropriate place. All right, well, I hope this helps prepare you for your objective check over FN6 through FND.